We are broadcasting. Excellent. Okay. Well, welcome everybody. I don't know how many people are out there just yet. I know that you just got out of your main meeting, but this is the Labs and Shops breakout room. My name is Glenn Thorncroft. I'm a professor here in mechanical engineering. I am actually standing outside of building 13, which is the main mechanical engineering building on campus. And we have several people here to talk to you about the lab and shop experience here at Poly. You'll notice I'm wearing my bling, by the way. Got to wear the ME swag. And so we have myself, Glenn Thorncroft, Dr. Charles Birdsong in the controls lab, Hans Mayer in the fluids lab, Professor and shop supervisor Eric Pulse is in the Mustang 60 shop. That's what we call it. And we have two students and shop techs, Rose McCarver and Brian Ford. So hopefully they might have waved when I mentioned their names. All right, so I'm going to take a minute here just to alert you that if we lose the signal or if the meeting were to stop abruptly, not like that would ever happen, just rejoin the meeting. We'll rejoin just in case there's some sort of snafu. These things happen. And also, as you probably know, this is a webinar, so I can't actually hear you or talk to you, but you can talk to us through chat or Q&A. And so if you send a chat or a Q&A message, Rose and Brian will be monitoring those. And then as we get a little bit further on in the video, we can, in the meeting, we can answer some of your questions. Okay, so, sorry. So as you probably know, we have something like a dozen undergraduate labs that are tied to the curriculum in mechanical engineering. So we're talking about from the freshman lab to a sophomore lab in measurements, to the thermal science lab and the fluids lab, the engines lab. There are labs all over the curriculum, at least 12 of them that I could count. And every one of them is an undergraduate lab, not graduate labs. We're undergraduate focused here. And you get to start from day one working in the labs. And those labs don't count the computer labs, the design labs. My count also doesn't include support courses like welding, machining, electrical engineering, physics, chemistry. This is a lab-heavy curriculum, and intentionally so, because we want you to hit the ground running with a hands-on education that you know what to expect at Cal Poly. So, definitely hands-on education from day one, so you can hit the ground running when you get your first job or even internship. So without any further ado, I thought what we would do is we'd spotlight a couple of labs. We have a few faculty here on campus. I thought we'd spotlight a couple of the labs and have some of the professors and the students show you around a little bit. So we're going to start with Dr. Charles Birdsong in the controls lab. So without any further ado, Charles, go ahead and take it away.
Hey, thanks, Glenn.
Mm-hmm.
On mute. Okay, so this is Professor Charles Birdsong in the Controls Lab. I'm here in Building 13 in the Parker Hannafin Controls Laboratory in the Mechanical Engineering Department. And this is one of the many labs we have at Cal Poly, and I really feel like the hands-on, learn-by-doing approach to Cal Poly, it really lives in these laboratories, because in these labs, that's where you're going to spend a lot of time. You're going to spend time with your instructor. Our labs are taught by professors, full professors, not by graduate students, but by professors. You're going to spend time with your classmates. In this lab, students spend 3 hours a week together. That's a lot of time to get to know each other's and talk to your instructor. And that's just this one lab. And as Dr. Thorncroft mentioned, there's many labs in our program. So our students will get a lot of time with real hands-on, learn by doing. And so I just wanted to highlight some of the things we have in here. We have the DC servo lab. This is the control of an electric motor. So controls is the math and science behind automatic control. So it's the math and science that you need for controlling robots and autonomous vehicles and manufacturing processes and things like that. So we learn how to control an electric motor. And then over here, this is our hydraulic apparatus. this is really the flagship of this laboratory. This was donated by the Parker Corporation, and they're a company that makes technology for instrumentation, sensors, and actuators, and all kinds of different things. And so they really believe in Cal Poly, and they donated a lot of money. It allows us to have this system in here. Okay, we're really proud of our labs because they're really hands-on industrial technology laboratories. They're very realistic. We don't have any sort of canned simple labs in here. Most of these things are made at Cal Poly, and they're very typical of what you'd see in industry. And this last one over here is our 2-tank experiment. And here we're controlling the flow of water through these pipes by controlling this automatic valve, and we can change the height of the water up and down like that. And so typically what happens in these labs is we have a sensor to measure the state of the system, so like the height of the water, and then we can control the flow by taking that sensor, sending it to a computer. The computer then processes that information, and with a real-time controller, it controls the valve. And that's typical of most of these in this lab. Now, every lab has a different theme and different thing they're trying to do, but in our lab, that's the theme that we're trying to deal with in our lab. Okay, one of the questions we always get in this lab is, what's with all the ducks sitting around? And the ducks are actually our mascot here. And there's an interesting legend about the ducks. And it goes like this, that one time, a long time ago, some students were sitting around the 2-tank experiment, and they were sort of bored, and they were just sort of looking at it. And the instructor, in order to kind of get them awake and interested, reached over, and he had one of these ducks sitting around. And so he walked over to the students, and he said, "What do you think would happen if I threw the duck into this tank?" And each student went through one at a time talking about their theory, about control theory, and what might happen in terms of disturbance rejection or sending it into an unstable situation. And then the instructor said, "Well, let's try and find out." And so he threw the duck into the tank, and lo and behold, the answer was nothing happened. And so it was a good joke. And ever since then, the duck has become our mascot in this class. But for me, actually, there's a different story. I'm not even sure that the legend is true, but I'll tell you a story that is true for me. A couple of years ago, I was working with some students, and they were here at the tank, and all of a sudden, the water stopped flowing, and they came to me and said, "Dr. Birdsong, there's something wrong with the equipment. The water's not flowing anymore." And so I walked up here, and this valve is supposed to be open, and the valve is open, but there's no water coming out. So I reached over, and I closed the valve, and then what happened was a little duck started to float up from the bottom of the tank. So what had happened is the duck had somehow got to the bottom and got stuck. The pressure was holding it at the bottom of the tank and stopping the flow of water. And for me, that tells a great story about our laboratories, because that's the sort of thing that doesn't happen in a textbook. That doesn't happen in a computer simulation. That's the real world experience that students get in our laboratories at Cal Poly. And so for me, that sort of tells the whole story. And that's what distinguishes Cal Poly students from other students. They have those experiences, those real world, hands-on experiences that they learn in all of our different laboratories. Okay, well, I think that's what I wanted to say. Glenn, should I hand it back to you?
Okay, I'm unmuted. So I figured what we would do now is see if there are any questions in the chat room. So Rose or Brian, if you'd like to bring some of those up, I can toss the video to you and you can talk about them.
So our first question is, what are some common internships that are available? If anyone wants to take that, or personally, I had an internship right after my freshman year doing HVAC. And then last summer, I interned at General Atomics, a major defense contractor. And this summer, I'll be going to Northrop Grumman, doing mechanical design. So last summer was manufacturing engineering, and that was really fun. Is there still a golf club design lab at Cal Poly?
Oh.
Anyone want to take that?
I'm actually not sure about that answer. I do know that there is a biomechanics lab on campus, which is really cool. And I know a lot of students don't have that or don't have access to it. in classes, but like you can go there on your own time and work on your own projects. And what they do there is they will put sensors on your body, so little retroreflective dots, and they have all these cameras set up, and you can swing a golf club, swing a tennis racket, and actually measure and put into CAD like your body going through that motion. So they don't necessarily have a golf club development lab, but you can use that for those purposes. Go ahead.
Pretty good. They got the hand signals. This is excellent. I know that who you're thinking about, we had a professor named Tom Mace, who was actually, his nickname was Ask Dr. Tom. He's in some of the he's in one of the golf magazines, I believe. And he's semi-retired now, so I don't know that he's doing much research in golf club manufacture anymore. But you know, there's always an opportunity to do a senior project on it as well. And I know that, harking back to the internship question, I believe that we've had some students go to work for some of the golf club manufacturers through Tom on their internships. So there may be some opportunities out there in the future.
One of our shop techs interned at Callaway, I think, two summers ago, something like that. So it's definitely an involvement that people can choose.
Good.
Okay, so our next couple questions are about working in the machine shops and whether students work in the machine shops and how do you get a job there. So I am a student, and so is Brian, and the thing that is unique about Cal Poly is that all of our shops are student run. We have Eric and Jim overseeing all of us, but for the most part, we get to help students directly if they come in with a project that they want to do. And how you get qualified, anyone can apply. Usually it's people who have more time in the shops, and anyone can come in and make projects and get that experience. Some people come in using their experience from Formula or Baja, the club project teams, because that gives them an incentive to come into the shops. But you can also do what I did and find an independent project that you want to just work on and gain some experience that way. So it really is self-guided.
All right, so we should probably move on to the our next presenter. Oh, great. Okay, so we should probably move on to our next presenter. While Dr. Birdsong was talking about the controls lab, I wandered over to the fluids lab. What I'm standing in front of right now is a wind tunnel. This is a 100-mile-an-hour wind tunnel, but Dr. Hans Mayer will be talking about that in a moment. So let me spin around and just say that he is at a safe distance behind me, and take it away, Hans. Very good.
Hello, everybody. My name is Hans Mayer. I'm an assistant professor in the mechanical engineering department and alumni of the mechanical engineering program, graduating in 2003. You're joining me in the fluids lab, and I'm going to switch cameras and drive you through the fluids lab and show you some of the experiments that students perform by Glenn during a junior year course that's tied to a second in a series of 2 fluid mechanics courses. So I'm going to switch my camera, and away we go. So we are going to drive through the fluids lab. One thing that's kind of different about that controls lab that you just saw is that the fluids lab here has plenty of space so that there are student workstations where before and after collecting experimental data, students can work in groups of either 2 or 4 to complete memos or other technical documentation that they're assigned. We're going to roll through here, and the first thing that you see right in front of you is the inlet to a 1 foot by 1 foot test section wind tunnel that we have in the lab. But the wind tunnel that Dr. Thorncroft was talking about was this one here, which is our 2 foot by 2 foot test section wind tunnel, which is capable of speeds inside the test section of approximately 100 miles per hour. So this is an example of a piece of equipment that students use in the course of a fluid mechanics lab. And we perform a variety of different tasks using this wind tunnel. So One thing that students do in the lab is they, what we call calibrate the wind tunnel, which is they relate the test section velocity or speed measured through something called a pedostatic tube, and this is an example of a pedostatic tube. They relate that test section velocity or speed to the fan speed, which is controlled by a variable frequency drive. And then once they have that wind tunnel calibrated, then they put into that test section an object, and this is a very simple object, it's a cylinder. And in that cylinder, about halfway from this wall to the back wall, there's a single hole which is used to measure the static pressure on the surface of the cylinder. And by rotating that cylinder, the students can measure the pressure distribution and then calculate what the overall drag force is on that object. So a major part of the fluid mechanics laboratory here is an introduction to aerodynamics, or the ideas of drag and lift, and what those are caused by. Okay? I'm going to come back to the cart over here, and to kind of answer one of those questions as I move around, this is my favorite lab that I instruct. So we're going to move this way, and we'll take you to another experiment, which involves turbomachinery. So if you ever hear somebody talk about turbomachinery, they're referring to a fan or a blower or a compressor or a pump. And those are ubiquitous machines that allow us to move fluids, so gases and liquids, through ducts and piping systems. So here is our axial fan experiment. And what we have students do in this experiment is measure what are called the performance characteristics of this turbo machine, this axial fan. And it's a little bit hard for you to see, but this is the axial fan here, okay? So inside of this duct, there's a rotating element. And when we talk about performance of a machine like this, and it could be performance of a pump or a fan or a blower, we're interested in knowing characteristics like the flow rate that the fan can deliver, the pressure rise across the fan at those flow rates, and how much power is required to operate it. And then we can relate that to the efficiency. So students generate then a set of performance curves for this particular fan, and they learn about what are called similarity laws or affinity laws for turbo machines. And once a student can understand the performance of a turbo machine like this, then they can really begin to think about selecting the best type of machine for a particular application. So I'm going to, again, move to the back of the cart, and we're going to turn around. As I do that, you'll see some other equipment right here in front of you. This is an optical bench, and this is an example of a student project where a senior for a 1-unit credit, it's called a special problems class, was asked to build a Schlierian optical system, which allows the visualization of gases or compressible flows. And so this is an example of a student project that's done inside one of our undergraduate laboratories. We'll move around here. And hopefully I'm not making anyone too sick by turning this. And here's another example of a piece of equipment. So fluid mechanics is, or at least fluids in motion. And when I say fluid mechanics, I mean the statics and dynamics of fluids. But when fluids move, there are pressure velocity relationships that we want to be aware of. And so this experiment here allows students to consider what happens to pressure and velocity in a flow with what's called streamline curvature, or curvature in the flow. And you can see a 90-degree bend. And so this bend is interminted with a number of pressure taps, okay, so small holes that are drilled in the wall of the duct, and those taps connect to tubes on the manometer board here. So students can measure this, and then relate that to a simple 1D and 2D theory. And the final thing that I'll show you, and then if there are any questions, you can let me know. This is a pipe flow analysis experiment. And so what students do in this experiment is, after spending maybe 2 weeks or so in class talking about predicting flow rate based upon, let's say, a height of a fluid in a tank and the components in a piping system. So in this case, the tube diameter, the tube length, the tube material, and something like an entrance here, and there's a well-rounded entrance. So after spending 2 weeks in a classroom, figuring out the theory behind that, predicting flow rate as a function of height, they can come into the lab here and actually measure volumetric flow rate as a function of height. And one of the neat things about this experiment is that when the pump down here, which feeds the tank, is turned off, then the tank begins to drain. And when we inject dye, basically food coloring, into the tube, students get to observe the transition from turbulent to laminar flow, which was first sort of discovered, if you will, by Osborne Reynolds nearly 150 years ago. So these are examples of experiments that students perform in a junior level fluid mechanics class. And then they work on write-ups, technical documentation in small groups. And it's really a unique, again, hands-on laboratory, much like the controls lab and much like all the other labs that we have to offer. So are there any questions?
Yeah, we have a lot of questions
Okay.
about this specific lab. I'm not sure if somebody was asking about this lab, but they're actually asking about the special problems class.
Uh-huh.
Does that have anything to do with your work in the fluids lab, or have any of the projects happened in this lab specifically?
So special problems classes are usually when students need 1 or 2 units worth of work to make up, for example, if they've gone to an overseas program for a quarter. And I believe this was the reason for this particular project, is the student had traveled to Germany and took classes for 1 quarter there. What the lab is also used for, I don't know if there are any other special projects or special problems classes projects that are in here, but this space is also used for students that are completing senior projects, which have some sort of fluid mechanics aspect to it. So over in the corner here, and I can wheel this around one more time, there's plenty of space for students to work on their senior projects. In that far bench over there, there was a funded project, I can't tell you which company it was sponsored by, that involved basically pumps and piping systems. And so they were allowed to work in the lab to take care of that, to build their instrumentation. Okay, so with that, if there are no other questions, I'm going to turn it back to Glenn, and thank you for your time.
Perfect. All right. So there'll be more chances for more questions as well after this next bit. But so I happened, while Hans was talking in the fluids lab, I happened to move over to the machine shop, which is not very busy right now, but will be we hope will be in the fall. This is the machine shop. This is one of 2 of the machine shops that we have on this campus for mechanical engineering students. This is called the Mustang 60 shop. And here to describe that shop, as I turn around very slowly and I turn toward the tool crib, and you zoom right in, and that happens to be Eric Pulse. So Eric, take it away.
Alrighty, so let me bounce off of my laptop and get onto the. There we go. All right, so now I'm on my phone like Glenn was. We're starting out in my office, which is not super exciting, but it is a place where the shop techs who do work for us get to basically do all the programming and whatnot for their the things they make here. And it's not just shop techs, and this is weird, it's reversed, and that's kind of wigging me out. Very strange. Anyway, so we go through the door, and we look at we have a 3D printer cabinet. Right now there's 3 in there. They're not being used at this exact moment, but they will house any 3D printers for students to use at any given time when they're available. There's no charge. Actually, the greatest thing about all of our machine shops is that there is no charge. No, that didn't work. I'm still trying to get the mic, like, why it's going, I broke it. Maybe that way. Sorry, everybody. All right, well, it's wanting to be reversed. So let's try this. I don't know why the video won't. Everything's backwards. So I'm walking down the aisle with looking in a mirror, which is a little strange to me. But if we go back to where I was, this is actually a MicroView sponsored metrology room. So the metrology room, we have a full CMM set up in the corner there, and a hardness tester, and there's actually an optical comparator in there. We do have 2 universal lasers in this shop. And again, all the tools in these shops are free. We do not charge to enter the shop. And actually, as ME freshmen, you are required to become certified to use the machine shops. It is actually part of your freshman series sequence to get into the shops and learn how to use everything. Right now, I'm standing in the metal shop of Mustang 60. Mustang 60 is about, the inside is 3,500 square feet and the outside is 3,500 square feet, so roughly 7,000. We have 3 Haas CNCs in here, 1 little TL1 lathe, and then we have our super speed VF3 and our super speed mini mill over there in the corner. We do have lots of manual equipment in here as well. There's a Bridgeport, an old Bridgeport J-head, and then a Grizzly South Bend lathe, and then a fairly new Bridgeport going on right there. As we keep going through the shop, we have a very small welding area inside. The larger shop, if you actually look behind Rose and Brian, the image they're both sitting in front of are is both separate images of our big shop, the aero hangar where all the cars are. And right now it is fully shut down. We cannot go in there, unfortunately. But that is where all the race cars live. This is the wood shop of Mustang 60. Full downdraft table. As I go along, we have routers, sanders. There's a panel saw in the back, saw stop, table saw. We try and actually do everything as state-of-the-art and safety driven as possible. The saw stop that's up the aero hangar was so early in its system. I think the serial number is in the double digits. My old boss who used to run the aero hangar when I was a student, I actually was an ME student at Cal Poly. I got my degree in 2005. He ordered the saw stops before they even came out. And so this is the one you look up on YouTube and the blade disappears when the hot dog cuts through, or when the blade hits the hot dog, right? So pretty awesome device. So we have tried to do everything with the highest safety factor as possible, state of the art in terms of keeping people safe. And we have over a quarter million shop hours with no catastrophic injuries. I mean, nothing more than a couple stitches. So pretty great. As I walk outside, this is our newest kind of enclosure. The courtyard out back is actually where our water jet lives. That's our brand new 10-foot by 6.5-foot water jet, Flow Mach 2. We've been busy in the times off. We actually won some really great auctions on equipment. So we have a brand new welding setup table that's out here right now. Nice wash down sink that's going to the hangar. And then a small paint booth and blasting booth that's over here to my left, which is your right, the way this thing's moving around. And then our welding area, actually, when we're done, is going to come out back. So we're going to actually have our welding and cutting and grinding and everything that's hot and loud is going to be behind the shop instead of inside the building. So anyway, that is pretty much Mustang 60. This is my pride and joy. This was an empty building when I was hired back here after I graduated. And it makes me sad to see no one in it. Normally there are people here probably, from about 6 a.m. to midnight, almost every day of the week. We had some questions about access and whatnot. And I did say that as a freshman, you are actually granted access to the shops. That is 100% true. There was also a question about becoming a shop tech. Once you pass your last class freshman year, you can apply to be a shop tech and join the ranks of our shop techs like Brian and Rose. It's a really great crew. Right now we have about 50 of them, and they are responsible for running everything in the shops. This is our tool crib for Mustang 60. This is where we pull all our hand tools and things. But yeah, that's try not to freak everyone out and spin too fast, but we pride ourselves on the students being the ones who run the shop, and they have gotten very good at it. and they enjoy it immensely. So I'm going to cut camera here and go back to my laptop. So if there are any questions or you want to see something else, let me know.
So Rose and Brian, if you would check some of the
So-
chat questions. Go ahead.
Yeah. So the shops are not open 24/7. We have usually we have Mustang 60 open Monday, Wednesday, Friday, and the hangars open Tuesday, Thursday. They're open from like 9 to, or wait. I should know our hours. I do when I'm usually working. It's weird when we're not working all the time. But oh, and then on Saturdays they're open all day. Both shops are. Oh, and then a red tag test is the way that we safety certify everyone. So as a freshman in mechanical engineering, you will. As a freshman in mechanical engineering, you will, get your red tag. However, any major can, and it gives you basic safety certification for the wood shops as well as like basic saws or drill presses or some metal working tools as well. And then after your red tag, you get a yellow tag where you can access more difficult machines. Do you have to sign up to use different machines? Everything's first come, first serve. If things are super full, which they usually aren't, then we do put up wait lists, but I've rarely seen that. That's usually only in crunch time for senior project at the end of each quarter. Cool. That seems like all of our questions for now. Please keep them coming. And
So
that Brian can give his.
yeah, so there was actually one question which I think already got answered via us just typing in the answer, but it had to do with something. Somebody said it looks like these shops are only for senior projects. That is completely false. Actually, I would say a lot of it is for personal stuff. Personally, I actually have a little presentation of some of the stuff that I made in the shops that I can go over for you guys, of just the stuff that I think is kind of cool. Let's see if I can share that. So the things you learn in engineering are going to be design the thing, build it, and test it, and then either ship it to consumers or put it as infrastructure. And the shops are a great way to carry out that entire process. So you design it at home or in class, and then you get to build it. So this is just a little slideshow of some of the stuff I've done. Start with my my bike, and I totally need to open this so I can actually click the buttons. Sorry about that. So design the bike, and then I actually made it in our shops. This is in the hangar of just mitering tubes. And then I welded it all together, and sometimes you find out that components don't fit onto whatever you make. So on the right hand side, I'm actually using a lathe to modify an existing bearing. I forget if that's the crown of the race of the head tube or the headset. And then I put it all together, and I actually ride that around today. And that's all something that I've done in our shops that I've had the opportunity to build in there. And that was for not senior project purposes. If you're not into bikes, then you can do a variety of other things in the shop on different machines. This router that we have is actually big enough to stand in. I did use this for my senior project, but I know people who have made guitar bodies on this. They've made ski molds. They've made those cool waterfall tables where you pour acrylic kind of plastic into it, and then it hardens, and then you get really cool tables out of it. And there's also a lot of creative people in here. They kind of do cool shapes for woodworking. Don't do what I did on the left. That's me turning wood on a metal lathe, but we work with what we have. So that was some woodworking you could do. We also have a lot of creative people who just like to paint things. So this is us actually making carbon fiber clipboards, which I still have on me. and we got to paint with some of the older shop techs. They came back and hosted this little how-to with us to make these cool clipboards. And then these are 2 titanium rings that I made for my parents. Definitely not a senior project. They just needed rings because my dad kept losing his. So, you know, I ended up making them a matching set, and then a few other cool things in the background there. And then last but not least is just, I make a lot of gifts for people. So this was one I made for one of my coworkers. We had a gift exchange, and she is on the Steel Bridge team. I don't know if you guys have heard about that, but they make really cool bridges, and usually place very highly in the nation. But she likes bridges, and I made her this photo holder that lights up and is shaped like a bridge. So there's a lot of cool things you can make in our shops. Hopefully when you guys come, you also utilize everything that we have and get to kind of experiment doing your own thing here. So I'm gonna go ahead and stop the presentation and open up to more Q&A.
I saw a question that keeps coming up a couple times about whether students have to buy their own materials or whether we provide materials. A lot of like the scraps that are around the shop is all fair game. So like we have a scrap wood bin or scrap acrylic for the laser cutter. And if you sometimes get lucky in the recyclables, you can also buy materials straight from us. We have assorted pieces of metal and things like that. But it's always a gamble. If you also want, like there's Home Depot nearby, I go there for materials sometimes or order online. And there are classes to teach some of the shop skills. So as a mechanical engineering freshman, you will go through a welding class where you'll get to learn a little bit of the basics of it so that when you come into the shop and are ready for your yellow tag to get certified in it, it's not completely foreign. Also, there's a mill and lathe class. But anytime there's a machine that you don't know, even if you haven't taken a class in it, you can always ask a tech and learn by just coming into the shops. Here's a question for you, Brian, what you're doing next year.
Yeah, I saw that. Thanks for asking. Thanks for being concerned. I am looking for jobs currently. A few in the Bay Area I've been talking to, and then one in SLO. We have there's good opportunities for engineering work in SLO, and it's an awesome area, so I actually like to stay here if possible. And I'm just kind of in the interview process with a lot of places. Right now, hopefully you guys don't have to deal with this too much, but everything is a little bit slowed, obviously. So I'm just kind of in that process still. It's an unfortunate time to graduate, but the good thing is Cal Poly goes a long way, and usually you have all sorts of connections that you can make just by people that you know in here, like talking to alumni and saying, hey, who should I ask, for a job at your company? I'm really interested. And then seeing Cal Poly on a resume actually goes a long way, and say, hey, that person has hands-on experience. So
I'm just going to screen share real quick and show a few of my random projects. While I'm doing that, wait here, let's go. What? Sorry. There we go. And slideshow. So when I first started in the shops, I was doing acrylic roses. It was kind of a nice way to do like art while also using the machines. So that's really fun and helps get my foot in the door. I got trained on the CNC, which is really exciting, and started to feel more comfortable with metal. I'm also currently operations and outreach supervisor at the shops. So what that means is that I've started up hosting events so that people who aren't as comfortable with the shops can be led through a project and get used to some of the different machines. So this was our ladies in the shop night. That was a lot of fun. Everyone made like a side table for their couch. Really successful. I personally am really interested in electrical engineering too, and so I took this class for fun where I built a radar system, and I came into the shops and used some of the stuff to put it all together, 3D printed parts and things. It's really cool because when you do want to, you can take classes that are outside of your major if it interests you, and if you make time for it in your busy schedule. It's hard to get through all the classes, but that's why there is the reputation of not getting through in 4 years, because there's just so many classes to take and so many labs, but it's totally possible. And as for me, next year I'll be doing my 4th year at Cal Poly. Here's just some other random things that I've made. And recently I joined Cal Poly CubeSat Lab, where we make satellites that actually get launched into space. So this is just a part that I made for that. But yeah, I think also it was really interesting because I joined the club this year. A lot of people join clubs at the very beginning of their career, but just anything that you feel interested in, there's always the door open. As for, there was another question that was asking about how everything's happening social distancing wise. That same wind tunnel that Professor Hans showed earlier, I saw him do a virtual video of that lab so that I could do the research and report. So a lot of the classes are doing labs online like that, where you can see a professor performing the lab experiment and record the data yourself. I also have a different lab. My electrical engineering lab is all virtually, like using a little circuit board, kind of video game-esque, where you're making the circuits. And yeah, let's see, other questions. Do any internships or travel abroad? So I talked a little bit about doing internships. I've done one every summer. And I think it was a really valuable experience. I learned a lot about thermodynamics and heat transfer before I even took the classes, because I had an HVAC internship and they taught me so much on the job, so that when I came into those classes at Cal Poly, I actually was familiar with brand new material. I don't know, Brian, you want to talk a bit about your internships?
Yeah, so I did not study abroad, but I did have an internship after my sophomore year. And it was with a startup company that made rockets in the Bay Area. And it was a really awesome experience that I actually got through one of Eric's friends who went to school with Eric, and then just emailed back to Cal Poly, and they said, hey, please send me, a few applicants who are interested, who you think could be like a good fit. And I got that job. And same thing with Rose, actually. I learned a lot of stuff there that I didn't know going into the internship, that actually propelled me further than some of my peers in the classroom. And obviously they caught up, but like, you do learn a lot of things in internships. You get some really cool experience just talking to people and seeing how real jobs work. And I think that's another great plus to being in the shops, is like, it gives you some experiences similar to mine and Rose's that are really unique in this day and age. As far as studying abroad, though, if you can fit it into your schedule, like, do it. I'll plug that right now. It's amazing. We have good programs.
Something that's unique about our study abroad program, I didn't study abroad, but I have had friends who have and loved it. And something that is different is that you can take major classes abroad. It's not like you can just take GEs wherever you go. You can actually go to Germany and learn actual engineering from their perspective. So that is very unique.
I think we actually have a breakout on study abroad. I'm not 100% sure, but if you're curious, you should definitely go check that out. TAMU. But usually it's a few, probably like 6 months before you plan on going. And definitely plan for it a year ahead. So, yeah. Had some great questions so far.
Yeah,
Hey, Rose, Brian,
awesome questions.
just an FYI to all the viewers as well. A lot of our faculty have taught abroad as well. I went to Munich a few years back. I taught for a summer. I would say probably 24 of our faculty have taught in Munich or other places, Spain, I think in Australia. There have been a lot of exchanges, not just by students, but also by faculty. So there's a chance that you could go abroad and actually take a class with one of your Cal Poly professors, weirdly enough. But it's a great experience. I highly recommend it for anybody who can do it. How are we doing on questions?
As for the language barrier for studying abroad, I've had some friends that have taken classes in German before going to Germany, so that way they are familiar with it. I think that's part of the program, but not 100% sure. As for like waiting when machines are being used, we have quite a variety of machines, and especially on a busy Saturday, if one of the machines is being used down in 60, likely it's not being used up at the hangar, or vice versa. So since both shops are all run by us, we can communicate and make sure that you're on your machine without waiting too long at all. And often you don't even have to wait. Let's see. Yeah, I think we have, how many mills do we have in total?
Are we counting the ones that we plan to add?
Manuals, there's 10 at the hangar. No. 9 at the hangar and 2 down here.
And then as for lathes?
4 lathes, 6 lathes if you count the 2 down here. And that's not CNC stuff, that's all the manual stuff.
Yeah, that's all manual. That's after your yellow tag, anyone can use those. And as for our wood shop, we have like pretty much the same wood shop down in 60 and in the hangar. And 3D printers never been too bad of a problem. So let's see, any other questions? Very cool.
And by the way, now these are student shops, by the way, but sometimes they'll even let professors like me come in and work. So show up freshman year, you might see me down there working on the laser.
Not really a question, but we got another comment saying that we're so impressive. We're just regular students. I think that we are, I mean, hopefully we're a little cool. I like to say that, but I like to think that our experience is not insanely unique. Everybody at Cal Poly has these opportunities, and they can definitely get to making such cool stuff that you see on like the webpage and just like in all the cool social media that we have out. So definitely, you know, be excited. It's a good time.
Are there more questions?
There's one that says, can you address patents and publications?
I can address this a little bit based on senior project things. Publications, you're probably only going to get if you are a grad student and doing grad research. However, some of the undergraduate clubs could possibly have publications at some point, like Crew and some of the experimental vehicles and things like that could come out of that. A lot of times something that's going to be a patent or a publication is going to end up being part of your senior project or a thesis. I know that the way our senior project system is structured, it is sponsored by industry companies and organizations. And so generally what will happen is a company will actually have something they want students to develop that actually will come with a non-disclosure agreement. In the past, I know that several students have been included on a patent for whatever it was they were working on. If you're asking more like, hey, I have an idea, I want to patent something, and that's kind of a whole separate animal, not really related to school. But however, if you do want to sponsor your own senior project, that could be a way for something like that. I don't know if that answers the question, but probably the best I got for you.
And Eric, we also have opportunities for undergraduates to work in research programs. There are a few faculty that do research, and they hire undergraduates to work in there. So And we have some summer research programs as well. So those of you who are interested in doing research, even though we're not a primarily research institution, there are opportunities there as well.
And so someone asked how long it takes to get your safety certification tags. Your red tag, anyone can take the test and come in. It's 3 hours for where we walk you through a practical portion and a written portion, just to know basic safety on all the machines. And then after 10 hours of working, just time in the shops doing things, and then an hour of cleanup, you can get your yellow tag.
Keep in mind, if you are an ME freshman, you will be, one of the freshman labs, your first quarter here will be taking the red tag tour and test. So you won't have to sign up for it. Other majors also require it, but actually most of the majors in the College of Engineering, your fall quarter freshman year, you will be certified as part of your freshman class for the red tag, not the yellow, but the red tag.
And if you are a change of major, part of the change of major class is getting your red tag again. So covers all the bases. Let's see.
How are we doing on questions?
We've got them all
Doing good.
so far. Waiting for any others to roll in. But yeah. Oh, as for how I got my internships, I think that that's often a question that I've had asked of me before. For my freshman year, I got it from the career fair. It helped that I had done research on the company. Always would recommend. And then for the second internship that I got, I sent out so many online applications. So, you know, sometimes people say like you can only get an internship if you have connections, but I really don't think that's the case, especially when you're coming from Cal Poly. And then someone just asked, what's the difference between the two tags? Brian, if you want to answer that. Or...
Oh, yeah. So the difference between the two tags is the red tag allows you to just be in the shops and use hand tools. Usually they're more or less wood tools, such as like the miter saw, just drill presses, stuff like that. And it's going to go over a lot of basic operations within our shops, how we check out tools, how we expect different people to behave, you know, stuff like when you go to a pool, you know, you don't run around a pool. We kind of teach that kind of stuff in the shops. The yellow tag is going to allow you to use mills, lathes, and welders, which are more or less like metal tools. And that's where we have a little bit of experience under your belt, not any experience using those machines, but just experience in our shops, knowing how we expect you to kind of deal with like making things in our shops, just so everybody's more organized and safe that way. So yes, you do get to use more and different equipment with both tags. And then after that, there's different processes for using some of the bigger things like CNCs, water jet, and other tools that we may get in the future. So thanks. There's a few other questions, especially in light of COVID-19. We have not had dorm experiences living on campus right now because we don't live in the dorms. So I personally can't answer that question. I'm not sure. I probably shouldn't say anything about it because I actually don't know anything about it. So does anybody want to answer that question? Dorm experiences?
I mean, I think it's always an adjustment when you're going to live in dorms, when you're not used to them. And I think it's really hard because yes, you are with a lot of people. So if someone does get sick and you're not cautious, it's easier to get sick. Even when I first moved into the dorms in my freshman year, it was within the first week I got sick, but it was just because like you're with a lot of people, you know. But I don't think it's as big of a concern. And I think that hopefully by next year, this whole thing will blow over, but you know.
I would assume the Residential Life website right now for Cal Poly would have concerns about COVID-19 addressed. We do still have several, probably a few hundred freshmen on campus that chose not to go home for the because they're from places like Seattle or LA or New York or something. And so they're dealing with it. I believe right now they put every generally you're going to have a roommate or two, depending on the dorms. But we've just built brand new beautiful dorms. There's actually more on-campus housing than there ever has been. So my guess is they'll have that addressed pretty soon, definitely by the end of the summer.
So this is actually a really common question. How much experience did you have with similar tools in a workshop before coming to Cal Poly? We get that a lot, actually. And I would have to say a lot of us did not have any experience before coming to Cal Poly. The cool part about the shops is it is a learning shop. It's not necessarily a shop where you're expected to churn out really beautiful looking products or even things that work sometimes. And just the process of building and seeing a design that you made in class come to life and maybe seeing it not come to life is a huge learning experience that we get a lot of our knowledge from at Cal Poly. That being said, some people do come in with a lot of experience and they get to make really cool stuff here because we do have the machines and everybody gets to use them. So it's kind of a level playing field, but you know, you do get to make really cool stuff.
When I first came in, when I first came in, I had experience with a laser cutter and 3D printers, but that was it. So all of wood shop was completely new to me, and metal shop, like, that was really intimidating. But the more you come into the shops, and especially with the freshman intro classes, you can get really comfortable with them. I think one of the big things, someone just asked what the difference, they're deciding between SLO and Purdue and how you would compare. I know that I don't know anything about Purdue specifically, but when I was debating on whether coming to Cal Poly, comparing all my other options, the big thing that set it apart was that ability to learn by doing and how many lab classes they have, how small the math and engineering classes are compared to these massive lecture halls in some of the other schools I was comparing. And I think that ability to have that, not only a bit like opportunity to go in and talk to professors so easily if you have problems, but also that we're actually making things and seeing the direct results of our lab classes is something that I think was unmatched.
Well, guys, we're gonna have to wrap this up. We're really happy you guys came here to watch the presentation. We know it's a little weird. It's a lot better if you were here. Trust me. Just the tour would be much more exciting. We'd be able to get to see a lot more of the labs. You can always contact the department if you have more questions. And otherwise, we hope to see you in the fall. And on behalf of everybody, everybody give a wave. There you go, Rose, Brian. Thanks, guys. We will hope to see you in the fall. This is a great program, and have fun. We'll talk later.